So on the first one, x equals -7 is in rectangular form. We know that x equals r cosine of theta. So then it's the same as r cosine of theta equals -7. We divide both sides by cosine of theta. And when there's a cosine downstairs, it turns into a secant. So the polar equation that is equivalent to x equals -7 is r equals -7 secant of theta. So if the square root of x squared plus y squared equals r, I can square both sides, and x squared plus y squared equals r squared. So I can make this r squared equals 25, but a polar equation typically is just r. So we square root both sides here, and r equals plus or minus 5. Whenever you see like equations like this, these are equations of circles, but the circle isn't in the center, so you can't just translate it. What we're going to do is FOIL that second guy, and that's going to be y squared minus 4y plus 4 equals 4. Everybody see what I did? I just FOILed that. Okay? X squared plus y squared is r squared. So these two turn into an r squared. And then we have minus 4, and y is r sine of theta plus 4 equals 4. So what happens when I subtract 4 from both sides?
Equals 0.
And this 4 goes away. So now I have r squared minus 4r sine of theta equals 0. Yeah? So if I move that 4r sine of theta over, I have r squared equals positive 4r sine of theta. And if I divide both sides by r, I get r equals 4 sine of theta. If you pull out your identity sheet, you will see that sine of 2 theta is 2 sine of theta cosine of theta, and that's on your identity sheet. That's just a famous identity. So then if I divide both sides by 2, get rid of that 2 over here, we get that r squared sine of theta cosine of theta equals 4. And here's where you have to kind of think outside the box. I can't divide both sides by r because the right side doesn't have an r. But I do know, what is x equal to? R cosine of theta?
Yes.
And y is r sine of theta. So if I take these two r's and I divide them up, I can give one to the sine and one to the cosine and make it equal to 4. And then I can say x, y equals 4. And now I have converted all my thetas and my r's to x's and y's. We don't have an r in this equation, but we do have a theta. And we know that theta, and in the first quadrant, you don't have to worry about x being negative, right, is the tan -1 of y over x equals 60 degrees. Got it?
Yeah.
So if I move that tan to the other side, I get y over x equals the tan of 60. Which if you look at your unit circle, the tangent is the number you wrote out to the side. It's √3. So y over x equals √3. It's on your unit circle. So y equals x √3. All in x's and y's.